This is Professor Mulford, and I just wanted to record a quick video to talk about the pH of salt solutions. And to do this, we're going to look at 4 different salts. We're going to look at potassium iodide, then we're going to look at potassium acetate, then we're going to look at ammonium iodide, and finally, we're going to do the other combination. Let's do ammonium acetate. And our question is, for all of these, when you put them in the presence of water, what happens to the pH? Is it acidic, basic, or neutral? Okay, so let's look at our first example here. And so we have potassium iodide, solid. We're going to put this in water. And then we're going to say, okay, what do we get? We get potassium ions, those are aqueous. And we're going to get iodide ions that are also aqueous. So what are these? Would either of these affect the pH? So the real question we're asking is, if we have potassium ions and iodide ions, how do they react with water? And we say, okay, what do I know about potassium? Well, really, that's the conjugate of a strong base, potassium hydroxide. Remember, the first row ions are inert. This is not going to do anything. We get no reaction here. Likewise, iodide is the conjugate of hydrogen iodide, the strong acid, so it also is going to have no reaction. So the potassium ions and the iodide ions can't react with water in any way to produce any sort of a change in the pH, so at that point our pH is going to be 7. Okay, so let's look at our next one here, which is potassium acetate. All right, so and we're going to have potassium CH3COO. Oh, forgot my carbon in there. And that's a solid. And we're going to react this in the presence of water. And we're going to get potassium ions. Okay, we already saw that those don't have any effect. But we're also going to get CH3COO. Just make that carbon there a little bit clearer. Okay, and then these are going to be aqueous. All right, now we already know, as I said, that the potassium is not going to do anything. So let's look at the acetate, CH3COO. And we think about this and we say, now wait a minute, acetate is the conjugate base of acetic acid. So it is a base. So it can react with water. It's a weak base, so we're going to have an equilibrium to make CH3COOH. And then it makes hydroxide. That's going to be aqueous. Okay, so we made hydroxide. So when we put potassium acetate in the water, the potassium is inert, but the acetate reacts with the water to form hydroxide. So that means that our pH is going to be basic. It's going to be greater than 7.0. Okay? All right, so now let's look at our next one. All right, our third example here was ammonium iodide. All right, take that solid. Let's put that in the presence of water and dissolve it. And now we're going to get ammonium ions. And we're going to get iodide ions. Okay. Now, earlier, we talked about iodide, and we said that doesn't have any effect on the pH. But ammonium, well, that is the conjugate acid of ammonia. So we can react that with the water. Again, still weak. We're going to get NH3 aqueous, and we're going to get, oh, it donates a proton, so H3O plus. Okay, so we made an acid. So when you put ammonium iodide into water, it creates an acid. And so as a result, our pH is going to be less than 7.0. All right. Then finally, we have the case of ammonium acetate. All right. So let's look at what happens here. Okay. Let's take ammonium acetate and the solid. Let's put that in water. And we're going to get out of that, sorry, ammonium and acetate. Okay, so we have now the conjugate of a weak base, ammonium, and we have the conjugate of a weak acid. So the ammonium can react with the water to give us ammonia and H3O plus. Okay, and then the acetate can react with water in our states of matter to give us OH minus. So we produce an acid and a base. Does that mean it's going to be neutral? No, it doesn't actually, right? Because they're different strengths. We need to look at the Ka here and the Kb here. And whichever K is larger is going to predict the pH. Why? Well, because remember, for every one of the sodium acetates that we put in, or ammonium acetates we put in, we get one ammonium and one acetate. So if you look this up, the Ka of NH4 plus, which remember you can get from the Kb of ammonia, just put that into the Kw, this is equal to 5.8 times 10 to the minus 10th. And the Kb of acetate is equal to 5.56 times 10 to the minus 10th. Ooh, they're really close together, but this number is a little bit larger. So that tells me that the ammonium is a stronger acid than the acetate is a base. And so in this case, my pH is going to be, well, my acid wins, so it's going to be less than 7.0, not by much. But you have to compare the two Ks to figure that out. So let's think about it for a second. What were our four examples? Right? We had, in example 1, conjugate of a strong and conjugate of a strong. Ended up neutral. In example 2, we had conjugate of a strong base and conjugate of a weak acid. And that ended up being basic. In example 3, we had a conjugate of a weak base and a conjugate of a strong acid. That ended up being acidic. And then finally, in 4, we had conjugate of a weak base and conjugate of a weak acid. Really, what you're looking at is just what are these things you're putting in solution? Is this material an acid or a base? What about that one? What about this ion? What about this ion? And you just look at the materials that end up in solution and you say, okay, do I have acids or bases? And that lets you know what your pH at equilibrium is going to be.